Hello all. Previously we have discussed how to implement stacks by using arrays. Now in this particular video we will see how to implement stacks by using linked list. So let's get started. So for that purpose we have a code in the dev CPP. First of all we have to create a node structure for the stack. So struct node, the value is int data. So in order to make a connection we have to create a self-referential structure struct node pointer next, so that the two nodes will be interconnected by the help of next pointer. So this is a single linked list node structure only. So if you have comfortable in single linked list insert at beginning and delete at beginning operations, so implementation of stacks by using linked list is a cakewalk, I must say. So first of all, create a global pointer called top and initialize with null. So if the top becomes null, then it indicates that the stack is empty. So top is a pointer which use it to track the stack elements, right? So if the top element becomes null, then the linked list is empty. Obviously the stack is empty. Okay, so instead of going through each and every line of the code, first of all I will go to the main function from where our compiler starts the execution, right? First initially the push 10 is called. That means we have to insert this 10 into the linked list. So let's see how the things are working. I will take an example. I will show you with respect to that example. So initially the linked list is empty. That means the stack is empty. Now we have called push function with 10 as a parameter. Initially top becomes null. That means the linked list is empty. Now create a node and assign the value. So I will show you the code. This is exactly similar to insert at beginning in single linked list. I will show you the code. Push, first of all create a node by using malloc function with the size of that particular node structure. Once that is created, assign the value. This x is should be there. That 10 is assigned in x, so x should be here. So assign the value in temporary data part. So this is what the diagram looks like. Temp data part, we have to assign that particular 10 value, that is the x value. Once this assignment is done, we have to link this temp next part. So initially the linked list is empty. That means the stack is empty. Now you have called push of 10. That means this is the first and last node, right? So in this part null should be present. So that is why top is null. Top is null. Now in this case, so temporary next should be assigned with null value. So after this line of the code, null is assigned in temp next part. Now previously top is equal to null. Now it should point to the first node. So by the help of a statement called top is equal to temp, the temp value will be assigned in top, so that top will be assigned to the recent element. Top will be pointing to the recent element. That is the meaning of it. So once it is done, again push of 20 is called in the code, right? Again, so after that if the node is got created, push it 10 onto the stack, like that it will be displayed. Okay, so initially we have called 30, right, or 20, I forget, whatever. So push 10, 10 is pushed onto the stack. Okay, like that it will be displayed. So again 20 will be called. So again push of 20 is called, right? Now previously the linked list having one node, 10 null, top is pointing to that particular first node. Now create a node and assign the value. Now in this temporary next part we should have the top address value. The top address value is 100, so that the interlink will be happened. The linkage will be happened, right? Now now the linked list is got created. previous the temp value is 100. Now temp should be moved to the recently added element. The temp should be pointed to the recent element. That is what the stack principle. The top is always at the recent element, so that we can delete that element. Okay, so that is the working principle of stack, which is nothing but a LIFO or LIFO, lost in first out. Okay, now whatever the address of temp, that will be assigned in temp I'm sorry, whatever the value of temp, that will be assigned in temp, but that will be assigned in top, so the top will be moved to the first node, that means the recent node. So this is the updated diagram looks like. Again we have called push of 30. Similarly we have created the linked list as follows. Top is pointing to the recent element. In this way the push function will work. This is exactly similar to inserted beginning in the single linked list only. If you are comfortable with respect to single linked list, this is a cakewalk. Okay, now display function will be called. We have to traverse the single linked list by using a temporary pointer. Take a temporary pointer and traverse through the list until temp becomes null. We have to print the each node value. While temp not equal to null, take a temporary pointer and points to top only. So temp data 30 will be displayed. Now top pointer should be incremented. Top is equal to top next, so that top, take a temporary pointer. Top should not be moved, because if top moves to the next location, then we lost the track of the recent element, right? I'm so sorry for this confusion. Take a temporary pointer and points to the first node and traverse the temp node. Okay, so while temp not equal to null, check the temp data and print the temp data. What is the temp data initially? 30 will be displayed. Now temp should be moved to the next node. How to do that? Temp is equal to temp next, so that temp will be moved to the 200th location. Now check if the temp is not equal to null. Temp is not null because temp is 100, right? 100 is not null. Temp is 200. 200 is not null. So check the temp data. 20 will be displayed. Temp move to the next node. 100 now. Check the temp data. 10 will be displayed. Now temp will becomes the null here. So null not equal to null, condition false, come out of the loop. So after this traversing, 30, 20, 10 will be displayed onto the output screen. So similarly you can call the pop function. Pop function will delete the recently added element, right? That means whatever the top value, that will be deleted. So initially the top is at the 30th node value. Now deleted begin function. This is exactly similar to deleted begin in SLL only. So let us see the code directly. Pop, if is empty, if the stack is empty, that means the top becomes null, then there is no nodes to be deleted. Check if the stack is empty or not by using isEmpty function. Go to isEmpty function. If top becomes null, then the stack is empty, then the linked list is empty in this case. So check that. But the linked list is not empty with respect to our example, so it is false. Take a temporary pointer and points to the top and check the temporary data. What is the temporary data here? What is the temporary data? Temporary data is 30. So 30 will be displayed now. So 30 will be assigned in popped value. That means the value to be deleted is 30, right? Now move the top pointer to the next location, so that top will be moved to the next location. That is top is no more at the first location. Now you can freely delete that particular temp, so that we have deleted the node at the beginning. This is similar to the deleted beginning in the SLL only. So pop is similar to deleted begin in SLL. No change at all. After that, return that popped value, and we have called the popped element is 30, and again display the element. Peak, we should not free the element, because peak, the definition of peak is without removing it, display the top element. Okay, without removal, you have to display the top element. That is the definition of peak. Go to peak, check if the list is empty or not, then return top of data. Don't free the top or temp here. Okay, now let us try to execute this code. So you can see 10, 20, 30 is added onto the stack, and initial stack elements are 30, 20, 10. Now we have deleted the recently added element, that is 30. 30 got deleted, and again we have displayed by using traversing. 20 and 10 will be displayed. Now after that, we have called peak function. Without removing, we have called peak function. The peak is nothing but the top value only. The top is pointing to the 20, so stack of top is 20 only, right? The 20 got displayed. In this fashion, we can implement stacks by using linked list. Thank you so much for watching. I will see you in my next video.